All right, here we have the practice problems for 7.4. So we're gonna just go through them pretty quickly. So number one, we have 2 to the 9th over 2 to the 7th. All right, so first we're just gonna expand it out. So 2 to the 9th, remember, is 2 times 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 2, 9 times. And if we're dividing by 2 to the 7th, that's 2 times itself, 7 times. All right, now the nice thing is everything's multiplying. And since that's the case, things are going to start to cancel off. So 2 divided by 2 cancels off. It's just 1. 2 divided by 2 cancels off. And again, so what we're doing is 7 of the 2's on top cancel with 7 on bottom. So we're left with 2 times 2, which gives us 4. So if you wanted to use our properties, it would have been 2, oops, let's change colors actually. Would have been 2 to the 9 minus 7th power, which is 2 squared, which is 2 times 2, to again get us to 4. All right, number 2, we have y over y to the 4th. So if we expand it out, on top we're left with just y, but y to the 4th is y times y times y times y. Now I'm going to do something here before we cancel. Remember, y is really the same as 1 times y. The reason I put that in there is when I cancel the y on top with 1 on the bottom, I'm still left with a 1 on top. It's 1 over y cubed. So if we used our subtraction property, or I'm sorry, division property, where we subtract the exponents, we would get y to the 1st power minus the 4th power, which is y to the negative 3rd. And remember, when we have a negative exponent, we want the inverse, so 1 over y to the 3rd. We should get the same answer. All right, number 3. Again, I could expand this out, or if I use my property, since we're dividing and we have the same base, I subtract my exponents. So it's going to be 2 to the 7 minus 2 power, which is 2 to the 5th. So it'd be 2 times 2 times 2 times 2 times 2. Now you can grab a calculator, or 2 times 2 is 4, 2 times 2 is 4. So we have 4 times 4 times 2. 4 times 4 is 16, and 16 times 2 is 32. All right, number 4, x to the 4th over x cubed. So expanding it out, x times x times x times x divided by x times x times x. It's 4 on top, 3 on the bottom. 3 of the x's on top cancel with 3 x's on the bottom, leaving us with just 1x. If we used our properties, we would have x raised to the 4 minus 3 power, which is x to the 1st, which is still x. All right, so now let's move on to numbers 5, 6, and 7. All right, on number 5, we have a little bit of work to do. In our denominator, you might notice we have a power raised to a power. So remember that's, m to the 5th times m to the 5th. So really we have m times m times m times m times m twice, or m to the 10th. So what's really going on here is we have m to the 5th on top, n to the 4th on top, over m to the 10th on bottom, and n on bottom. All right, so I'm going to start by expanding this one out. Five m's on top, 4 n's on top, 10 m's on bottom, and 1 n on the bottom. So now if we're canceling out, I know that 5 of these m's on top cancel with 5 of these m's on the bottom, since everything is multiplying, and 1 of the n's will cancel with the n on the bottom. So that gives us n times n on the top, or n cubed, over m times m times m times m times m is m to the 5th. So if we solve this with our properties, and we subtracted the exponents, we would have m to the 5 minus 10 power times n to the 4 minus 1 power. So we would have m to the negative 5th times n to the 3rd. Now remember, m to the negative 5th is 1 over m to the 5th times n to the 3rd. And if I wanted to, I could rewrite this as 1 over m to the 5th times n to the 3rd over 1. So when I multiply straight across, I just end up with n to the 3rd over m to the 5th. Because 1 times n cubed is n cubed. 1 times m to the 5th is still m to the 5th. So we end up with the same answer. All right, on number 6, we could just solve all of these values and plug them into a calculator. But to make it easier, we're going to use the property to shrink our numbers a little bit. So we want 3, and then the exponents are 5 and 4, and if we subtract them, 5 minus 4. The next common base we have is 2. Those exponents are 4 and 2, so 4 minus 2. And then lastly, we have 4 raised to the 3 minus 6. So this gives us 3 to the 1st times 2 squared times 4 to the negative 3rd. And I'm going to go ahead and write that negative exponent as the inverse. So 3 to the 1st times 2 squared times 1 over 4 cubed. All right, what I'm also going to do is write 3 to the 1st over 1 and 2 squared over 1, just to make it easier to see what happens when we multiply our fractions. So multiplying, actually let's take care of our exponents first. 3 to the 1st is 3, 2 squared is 4, and 1 is 1. All right, on bottom we have 1 times 1, and then 4 cubed is 64. So multiplying straight across on top, we get 12. On bottom, we get 64. And I notice that both of these values are divisible by 4. So if I divide everything by 4, I end up with 3/16. That would be my final simplified answer. So all of that junk just simplifies down to 3/16. All right, last one. Here we have d to the 4th times e cubed over d times e, both raised to the 2nd power. So if you've forgotten this property, since the d and the e are multiplying together, we can think of this like de squared is de times de. The commutative property lets me rearrange things, so I have d times e times e. In other words, each of those variables got squared. So I have d to the 4th times e cubed over d squared e squared. So if we just expand this one out, d times d times d times d times e times e times e over d times e times e. And again, because everything's multiplying, that's what allows us to cancel. So d times d cancels with a d times d, and e times e cancels with an e times e, and we are left with just d squared times e. If we used our exponent properties, d has a common base, and the exponents are 4 and 2, so we would subtract those. And e is our other common base, and the exponents are 3 and 2, so if we subtract them, we end up still at d squared times e to the 1st. All right, so good job taking care of these practice problems. Let's go ahead and take care of our LT check.